Hi guys, this is my first video where I program some stuff. In particular, here I will do a tutorial about an easy Spec UI because some time ago I was bashing Spec like mad, and I realized that I should do a tutorial about that so more people will know how to use it. And this is my first video, so don't be too mad on me if I do something bad. The idea is simple. You probably have seen this stuff at some point, which are refactoring browser rewrite rules. And if you're like me, you would ask yourself, like, what the hell is this statement? And what is this temps? And this is each with a backtick, but not with the @ sign. And there is a documentation about that, but if you want to check how it works, you have no real way. So, for example, when I have to do something with the regex, I am going to Ruble our website where I can type some stuff and I see what is matched. And then, for example, if I want to match a group of digits, then I have all these matches here and I can sort of analyze like what is happening there. But you cannot do it with this stuff. So we will make a really simple Spec UI for that. And yeah, essentially we will just start from coding it. So we should subclass a composable model, which is a Spec base class for UI models. And let's call it a MatchTool. And let's put it in the package with the same name. First of all, I really hate these exclamation marks. Please don't leave classes uncommented. Put at least something simplistic like this is a tool for checking RB match expressions. And let's see, testing and inspecting the results. At least someone will know what this class is about. And let's add an instance variable. So first instance variables are the things that hold UI elements. So we will definitely need some match expression, which will be text area for match expression. Then we will need some test expression to see if the match expression matches test expression. Then we will probably need some button to actually make it run. So let's make an execute button. And then we need to show our results of all matches. So let's do a result list. And then if you remember, there were these wildcard variables with backticks and so on. And we want to know what they are mapped into. So let's do a match map list, which will contain all the mapped variables. We have these variables, and now we should add accessors to them, getters. And let's uncheck all the setters because we don't really need to set anything from outside. And let's add this getters. This is good. And then let's initialize our UI elements. There is a method for that called Initialize Widgets. And let's do that. So first of all, we have a match expression, which will be self new code. Spec provides this handy initializers for basic widgets. Then we have a test expression, which will be also a code. Then we have our button, which will be a button. And And then we have to list. So result list will be self new list. For match map, we will add a multi-column list. So first column will be the wildcard expression, and the second one will be what was mapped to it. So there is a new multi-column list. While we are already on this stuff, we can essentially do the initialization of focus order, which is done like this: set focus order. If I'm not, no, just focus order. And here we've given an array of the elements. Let's just put it in this order. So first we would like to enter the match expression. Then we would like to order a test expression. Then we need to execute it, and then we probably need to see the results. So we already have our UI elements initialized, but now we need to tell our thing how to display them. For this, we need to put a method on the class side called default spec, and it should return a layout. So how do we do this? We say spec layout composed. At the beginning, let's say we have one row where we will have columns. So we can just say new row, and then we have a block where we need to initialize this row essentially. And then for this row, we will say, okay, add a new column, because in the row we will have columns. New column, and then in this column we will have rows. Sorry, we have to initialize the column, and in this column we will have rows, but we can just say add, because it's clear that we are adding rows in a column. And first of all, we need a match expression, and then we also need the test expression. After this column, we want to have another column. And this column will have a button to run the stuff. And so execute button. These symbols that we put in here are actually the methods that will be called. So that's why we need accessors to our instance variables. And here we also will put a result list. And then we will have the last column. Where we will have the match map. Match map list. Right. Don't forget that in the end you have to return yourself, because otherwise it will just return like a new column that you create. This is good enough. Let's categorize this. And I guess this should be enough to launch our thing already. So we will have our match tool instantiated and open with Spec. Boom, we have this. So this is our match expression. This is our test expression. This is our big button. This is the result list. This is the match map list. I think we need to change proportions a bit. Let's say we will shrink the button in the first place. So what do we need to do with it? When we say add button, we can also say add this thing, and here we are adding a row because we are adding it to a column. So rows have height. Width is variable. But height can be essentially settable. My English is bad. Sorry. So now we have this button which is smaller, and this is nice, and it gives more stretch to our result list. But if you think about that, these areas are for actual code, actual text, and they should be probably wider, while the result list can be smaller, it can be thinner. That's why Spec gives you a possibility to define the exact percentage where you want your thing to be. So we do this with the add column origin corner method. And here origin will start at 0, 0. It will stretch all the way down to 1, but let's make here it half the size. Okay, and then we don't need a semicolon here. Then for next column, we need to put it starting and at 0.5, and then let's say it will end at 0.75, and then for the last column, we will start at 0.75 and drag it till the end, till the 100% of our parent widget. So we set this to our main big row, and essentially we have to say this to the column, make column like that. And now, bingo, we have a larger place for our code and smaller place for our results. Good. Now, why did we need this new row? We need this new row because then it knows that things are in the row, and then they put them proportional to have like 1/3 of each. Now, as we have hard coded kind of the percentage where they should be, we can just remove this row stuff and add everything to our main layout. So you can see it works completely the same. I hate how it's opened really small. So what we will do now is we will implement the extend method, which will return, let's say, 800 by 400 pixels. Much better. And then let's also add a title. And let's say that this is a match tool. So now when we run this, it will have a title, and also the tab will have a title, so it's easier to find it. We have already instantiated the widgets and created a layout. So now let's go into some functionality and representation. First of all, let's style our button a bit. Okay, we have already a lot of code here. Let's throw away this into another method because it's quite a simplistic code. And let's call this Instantiate Instantiate Widgets, and you can see that it creates a new method, and here it removes all this crap. Good. And also let's move this thing outside because it's ugly to have everything here. Initialize focus. Nice. Now, initialize widgets should be used for kind of initializing them and defining how they look. So what we'll do here, we will say, okay, execute button. We want to have an icon here, and the icon will be a small do it button has no, not button, small do it icon as icon. How do you know that this is really an icon? Well, just inspect it, and it's not an icon because morph is empty, so probably do it has capital I. And now you can see that it's actually an icon, which is green arrow. Also, we will put a label, which will be match, and we will also put a shortcut, which will be character CR. So essentially, if you use character enter, it's not really always working, so it's better to use character CR. And then meta. Meta is a special way to say that it's a command on a Mac or a control on a Windows and whatever it works on the other systems. This should work. Let's execute this. Yes, we have a nice button. And yep. And now let's think what we want to have. So these text areas will accept some kind of code, and then they need to do something for this orange triangle to accept it. And this is some kind of action, and it's good to put actions in Initialize Presenter method. Let's do the super initialize presenter. I have no clue what it does, but then let's initialize how our text areas are going to react. So we have match expression, and let's accept block, I guess. So we have accept block, which gets a text which is going to be accepted, and then let's say self accept match expression text. Okay, and then we have to implement this. So what will this do? We will use RB parser, parse rewrite expression text, and then if this fails, we don't want to accept the text actually. So on syntax error notification, what we want to do, well, maybe we will want to tell the user in the future what is wrong, but at the moment not drill into that because it's actually complicated a bit. But we will just return false, because when this accept block returns false, it's not accepting it. That's why we do this. Also, this will parse the rewrite expression and will create an AST. So let's store this AST somewhere, and let's call it match node, and create a new instance variable for that. Yeah, it's complaining that I'm returning a Boolean and non-Boolean, but essentially the accept block, the return is checked for identity with false. So at the moment it's fine. In future we will refactor it to work more smartly. Also, let's do this for test expression, and then we will just parse an expression because we want to match it against a real expression, not a match expression, which will be weird. And let's do a test node. And we will have an instance variable for that. So you can say that these methods are quite similar and they should probably be refactored somehow, but we will do this later because these two areas are actually quite similar. So you have to do something smarter than just playing with methods. Let's finish initializing our presenter. So we want to have the same stuff for testing. Match test, test expression, accept block, and then we will say accept the test expression. This should work. Let's test it. We have some var here and we save it and it works. If we are sending message 1 to var, which is not possible, this is a syntax error, we try to save it and it's not saving it. So this is good. After we have these things working, we should go to the match button. So again, this should be in a presenter. And then we say execute, we need a period and statement, execute button action. What do we do at action? Well, we actually are doing self perform match. That's it. So now we have to implement how this perform match is working. First thing that we want to ensure is that our text areas are accepted before matching, because that will be strange if you have some text there and it's matching against some other stuff which was accepted previously. So what we're doing here is we are saying match expression accept, and also test expression accept. Now we need to also check if there is nothing strange going on, like whether both things are accepted, because if they are not accepted, then probably there was some error. And if both nodes are not nil, because if you just initialize our thing and didn't type in any text, then they will be nil. So let's say just if self is ready for match, if false, we will just return, and that's it. Otherwise, we need some collection of matches. And let's initialize it here. So let's say it's an ordered collection. And then we need to actually match the stuff. So let's take a test node. And what we want to do, so there is a match expression and there is a test node. So when you have some node, you want to actually go over all of its children and test it against match expression. So if you want to match some kind of variable, you want to traverse all the children and collect all the variables that match the expression. So what we are doing here, we are saying nodes do, which performs the block here on itself and on all the children. And then we say match, match node, try to match this current node. And then there are two options. It may succeed and it may fail. If it fails, we don't care. if it succeeds, there is an optional argument in this block, which is a map, what variables were mapped to which stuff. We want to store this for future, and at the moment we will use a simple association. So you will say, okay, matches add node, because we know that this node was matched. And then we will also say that we have this map of matches. Okay. After that, what we want to do is we want to say result list items are now like this. Okay. Cool. Really simple. Except two things. Check if everything is fine. Create a collection of matches. Traverse all the nodes of the test node. Then for each node, check if it matches the matching node. If it does, store the match into the result. That's it. Then we put the matches into the result list and it displays the stuff. We are missing at the moment is ready for match, which should be straightforward. Essentially, what we are doing is we are saying match expression has unaccepted edits. So if match expression has unaccepted edits, or if test expression, we actually should return this. Then we can do this. Has unaccepted edits, or if match node is nil, or if test node is nil, right? And so if one of things has unaccepted edits or one of things is nil, then it's not ready. So to say that it's ready, we should negate all this stuff. That's it. Theoretically, we should be able to run it. Let's try. Let's say that we match some variable, and then let's say we have some name here, like a variable, and it matches. It works fine. We have this match here. Let's add another statement with name 2. No, name 2. And then you can see that it matched name and name 2. Output here is not nice. That's our next goal. So let's go to Initialize Widgets, where we define how the widget should look like. And let's say that for result list, display block is the following. So we take item, and then we say item. So if you remember, the match node was the key and the mapping was the value. Let's say that this is association. So if someone reads our code, he knows that the item is an association. And we take a key, and you have seen that there is a RB node. We say formatted code to print the actual code and not the node itself. Let's try to run this again. We have the same var, and we have a name, and we are doing this. We have a name here. Cool. Now, when we press the name, we want to see what is up here, right? What the var was matched, because if we say var as string, we want to match var as string, we send a string to name is definitely matched, but also you want to know that var actually matched the name. And that's why we have this mapping stored. So let's say what happens when you actually click this stuff to display things here. We should do this in the presenter because this is how widgets interact inside of our model. So let's go for it. We say result list when selected item changed, selected item changed, we get the item and we say self selected result item changed. Let's say selected result item changed. So it is clear what is happening. What should we do here? Essentially, when an item is changed, we need to update the mapping stuff. If you are not aware of this, if everything is deselected, then item is essentially nil. We should also handle that. So if our item is nil, we want to put there an empty array. Match map list items is an empty array. If it is not nil, then match map list items should be item. You remember there is a key which is a match node and value which is a dictionary of matches. So let's again extract associations from the dictionary, which will be item value to get a dictionary and associations to get the associations. Besides that, we also have to define how it displays the stuff, which we are doing again in Initialize Widgets with display block. But here it's more tricky. If you remember, it's multi-column list, so it expects us to give it an array for each with a string for each column. So how we are going to do this? We have a key which is a matching node and the value which is a matched node. So we just have to convert this into array. Match map list display block. Here we will start our array. So we take formatted code from a key and formatted code from a node. And that's it. And theoretically, this is enough to make it work. So let's say we have a var here and we send as string. So we want to find any variable that gets a string message. And we have some name to where we send as string. And this is working. And then this stuff just explodes. Okay. I forgot to do some stuff. Of course. Because here I'm saying a node, not a value. Sorry, my bad. Let's do this again. Var as string, and here we will have name as string. Bam, go here, you see this. So you know that you matched name as string. Imagine there will be just a name in the following statement. You matched only name as string and var was matched to name. I have now to tell you one nasty thing that I had to do. So as you can see here, we are expecting to have refactoring browser AST nodes, so we are sending formatted code. But for some magical reason, sometimes during matching, it also stores the symbols, plain symbols, and it also stores ordered collections, which is why I have this extension in string where I essentially say formatted code is just self. So if you have a symbol, then it returns self. And also I have an extension in ordered collection where I because collection has the nodes. And then for each node, I say, okay, do the following thing, put the formatted code of a node, and then put a period after that, because ordered collections are used only if statements are matched. And then you want to put a dot between each statement. I hope this will be fixed in the future in the matching mechanism itself, but for now we have to overcome it in this way. It looks nice so far. What else do I want to do is I want to make sure that, for example, we have name a string here, and imagine we do name one a string here, and then it updates the stuff and it's still kind of selected, although it's a completely new list here. So let's say if we put a new list, we remove a selection, and let's say we don't want selection here because I don't know what it should mean. And also let's say when we select this stuff, we want to have a highlight here. So let's go for the highlight first. Let's categorize these things and see if it works. So this is API, I can agree with that. This looks like initialization, which is good. This is testing. I wouldn't call this a visitor because this is event handling. This is event handling because event happens, like you want to accept and you need to handle it. And then perform match is also an event handling. And then this is also an event handling. So let's go into event handling and update this thing. So when we deselect a list, we want to make sure that our selection on the testing string is cleared. So I think it's called test expression clear selection or not. Let's try to do this. Maybe it helps. Let's check if it's, yes, it's in text model. So we are good here. Otherwise, in this case, we'll say test expression set selection to be item key, which is a node that was matched. I think it's code in, no, it's source interval. Yes, good enough. And then we want to do something when the list is changed. So let's shift this to the next line and cascade into another event. When list changed, and there are a few optional arguments, but first is a new items, and then there is old items. Not to pollute the space, I will just say self handle list change from old items to new items. And then how it should handle that? Well, I think it should be quite simple. So what we are doing here is we are first checking if old items are not the same as new items. Then we want to remove the selection. So if true, what should we do is we should say result list reset selection. Yeah, this should be good enough, I guess, so far. Let's do that. So let's check if we match a var. And if we match a name with an error, and then you see this thing is accepted and this thing is not, which doesn't move us forward. Which is probably that here we should say that there is a problem, but we will do this later. In this case, it works. We select this. It sees that if we accept it again, it does nothing because the result is completely the same. But if we put a name 1 here, and then it matches name 1, it's completely different stuff. And you click here, and you see name 1. Now, why do we need this? Well, imagine we have var, and then we have some message, and then we have a, and then we have foobar. And this thing is matched, and you see that var matches a and message matches foobar. But imagine that you also have b and buzzbar. So now we have these two things, and you can see the highlights here, which actually help you to understand what is happening. But imagine that you put a foobar something, then you see that this, only this is matching. And this is helpful, and then we say that a equals to this stuff. And although the result is the same, but you can actually see the highlight where it is. And here we can have the same foobar. So you can see two matches, which are identical, right? But when you click on them, you can see what is highlighted, so you get an idea. Maybe it makes sense to make this selection to highlight it here, but for now, no. We'll just say in widget initialization, no, not self, match map list accept selection false. So I think it's allow to select. Yes, false. Actually, we are already working with this list a bit higher on our code here. So let's just cascade this. And let's play with our tool. So let's just do a trivial check again. Name, it works. This is not selectable, very good. Now, if you recall the code that was really popular for demonstrating the functionality, imagine we have some. So this at sign means that this is a list of expressions. We have some expression, and then we ask it is nil, and then we say if true, do some block code. And this was used to essentially match this stuff and rewrite it to if nil. But what if you want to test this? Like, what is matched? And then you say, okay, let's do some nil if is nil, if true, let's say transcript show A. Okay, maybe we should make these things wider, but this is not that bad. So you can see that this expression was matched. It's highlighted here. Imagine that you have some variable result, I don't know. Then still only this part is matched, and then you can see that expression pattern is matched to nil, and block code pattern is matched to transcript show A. How cool is that? And then you want to check, well, you want to replace everything in a block. What if there are two statements? Does it work? No. Why not? Well, because this just matches a list of expressions, and if we do things like that, adding a dot, it matches statements. So now it matches this stuff, and you can see what is matched here. And then you may think, well, I use this, but I'm not sure if I have just this single expression. Is it working? It is. So this is how you kind of go into there and debug the stuff. And lately there was this thing, there was a change of API, how you look for icons. So now you use something as icon, but it wasn't like that some time ago. And actually some time ago it was like this, and everyone was doing that. So he was saying matches something. So we can try to match some symbol, and let's check for a real usage. This is good enough, or we can even copy it with a return statement. How cool is that? And it's not matching the stuff. Is this because of a return statement? No. Or maybe I am missing something. Yeah, now it works. I wonder why. Well, it works. It's good enough, I guess, even with the return statement. It selects the part, so it matches it, and you see that symbol matches class icon. But maybe I just want to match symbols, and what if I have something like self foobar? And it also matches that. And essentially I know that if I put hash here, it will match only literals, at least. And then it will not match that, but it will match thing like this. And you can see that symbol matched an icon. So this is the main idea. I think it was quite simple to use Spec to build this UI, and it's so powerful. Like you can just code your match expression here, code your text expression here, and then try to see what matches them. And this is super cool. Probably you've seen that I almost never press this button because I have shortcut on Command Enter, and that's what I was using all the time, so don't be confused. Additionally, you have seen that we use code areas, new code, but we don't have a highlighting, right? Well, this is a hard case because Spec was moving to rubric for text areas, and what we need to do is we need to say match expression about to style true, and also test expression about to style true, and then it should work. So we can say small talk UI uh, icons, icon named var expression, and then we do the same stuff with something, and it completely works. The problem is that this thing is not highlighted well because it uses standard parsing for highlighting, and this requires rewrite expression parsing. So we will work on this in the next video if I make it, but please, if this helps you at least in some way, or you think that these videos can be helpful, comment down below the video so I have any clue if this makes sense for anyone, if it helps anyone. And also, I don't know, at least put a thumb up if it's good, or thumb down if it's bad. So at least I have some clue if anyone cares about this stuff. Other than that, yeah, that's it. Thank you for watching, and I hope to see you next time.